Welcome back, Science 10. So today our lesson here is going to be on naming and writing formulas. So something that we learned back in Science 9. So I'm just going to kind of quickly go through it, explain the rules, and then you'll get a chance to practice. And once again, if you have questions, please feel free to ask me or email me. So naming and writing formulas. So we're going to start with ionic compounds. And a reminder, ionic compounds is when you have a cation and if you have an anion. So I think I'm mirrored. So when you have a cation and when you have an anion, and they come together due to the attraction of a positive and negative ion. And so, for example, number one here, write sodium sulfide as its chemical formula. So if we're writing kind of chemical formulas for ionic compounds, step one, we want to determine what the symbol of the element is. So sodium, we look at the periodic table, number 11, Na. Step two here says determine the symbol of the second element, and remember that the ending IDE, ide, means that the name represents an element on the periodic table. Look for the element with the same beginning to its name. So if we're trying to find sulfide, we'll never find sulfide on the periodic table, and that's because sulfide is actually a combination of the sulf from sulfur and an IDE ending. So sulfide, its name comes from sulf plus ide, and so what we're going to look at on the periodic table is sulf, in other words, sulfur. Sulfur with a symbol of S. Once we found kind of the two symbols, we're going to place the two symbols side by side in order. We're going to write the charge found from the periodic table at the top right of each element symbol. We're going to ignore kind of the plus or minus for now. Okay, so this is 1, this is the plus, and this is the 2 minus, but we're just going to put 1 and 2 for now. Then we're going to cross over the charges. So by crossing, I mean kind of crossing it down. We're going to cross over the charges so that the number becomes the subscript. Right? The 1 becomes the 1 behind 2. The 2 becomes the 2 behind the Na. So here we have Na2S1. Step number 5, reduce the subscripts if they have a common factor. Delete all the 1s. Okay, so 1s, we're going to delete that. And so the final answer is going to be Na2S. Now things get a little bit trickier when we have polyatomic ions. And so what polyatomic ions are is they're ions that have more than one element associated with it. So for example, if you're trying to find ammonium sulfate and you try to find ammonium on the periodic table, you're not going to find it because ammonium is not a single element. Rather, it's a combination of multiple elements. And so we flip to the backside of the periodic table with the list of the polyatomic ions. We find ammonium to be NH4+, and we're going to write it here. Step number 2, okay, sulfate. Now, we might be tempted and say, oh, sulfate came from sulfur. But remember, if it came from the periodic table, the ending would be changed to an IDE. This sulf is not a sulfide, it's a sulfate. Okay, so sulfate, if you look on the periodic table, it's a polyatomic ion with the formula of SO42-. Once we identify the polyatomic ions, we're going to treat them the same way. We put the charge, so NH4, 1, SA4, 2. The only difference is we're going to put brackets around each polyatomic ion. So NH4, it's a bracket, 1 at the top. SO4, it's a brackets as well with a 2 on the top right. And then we're going to do the same thing where we cross over so that these charges now become the subscript of the other ion. Same thing, we're going to reduce the subscripts. Okay, so 1 is gone. And if there's no subscripts following the brackets, we can move the brackets as well. Okay, so ammonium sulfate is going to be, in brackets, NH4, 2, and then SO4. And then to complicate things even more, sometimes we have multivalent elements. And so multivalent elements are usually transition metals that have more than one possible charge. And so for example, iron 3 chloride here, you'll notice that behind iron, there's the Roman numeral 3. And that's because if you look at iron, number 26 on the periodic table, you'll notice that there's 2 possible charges iron could be. Okay? It could be 2 or it could be 3. Or iron could be neutral and have no charge at all. So the 3 there is telling us that this iron is going to be Fe3. Okay, if it was iron with a Roman numeral 2, then that means we're using Fe2. So the Roman numerals tell us what the charge is, and then everything else is the same, right? Fe3Cl chloride is a -1. Okay, so Fe we're going to cross. Okay, by now you're probably a little bit more comfortable with crossing the charges. If you want to leave the 3+ or the negative, that's fine. The charges become the subscripts of the other element. Reduce it if it is a 1 or if there's a common factor, and our final answer here is going to be FeCl3. Okay, so there's some practice here. Once again, you can pause the video and kind of work on these practice questions, and when you're ready, you can then turn this video or continue playing this video. Okay, so hopefully the formulas of your ionic compounds look the same. Double check. Once again, if you're having issues or you're having trouble, please feel free to email me. Okay, so now that we've done kind of writing formulas for ionic compounds, we're going to go ahead for covalent compounds. Now, one easy way to recognize covalent compounds is to take a look at the first element and the second element. If both of these elements are on the left side of or the right side of the periodic table and they're both nonmetals, that means you have a covalent compound. So easy way that I like to recognize whether a compound is ionic or covalent is to figure out if it's covalent or not. If both of those elements are in the same right side of the periodic table, then it's going to be covalent. Anything else, it's going to be ionic. Usually writing or dealing with covalent compounds is a little bit easier. Let's go ahead and take a look at this example. So write sulfur hexafluoride as its chemical formula. Step 1, look at the first part of the name to identify the element and the number of them you need to include. If there are no prefix, that is the same as mono or 1. So first part of the name, we have sulfur. So sulfur, no prefix in front of it, so we only have 1 sulfur. Step 2, we're going to do the same thing for the second part, hexafluoride. So hexafluoride, fluoride is fluorine, hexa is 6, that means we have 6 fluorines. We're going to ignore the charges, do not cross them over, we're just going to write the numbers of the subscript. Okay, so charges only apply for ionic compounds. If it's 1s, it's just going to be S1, F6. Just a reminder that if you've forgotten kind of what the prefixes are, they are on the backside of the periodic table as well, so you don't have to memorize them. But it does make your life a lot easier if you can memorize most of these. So for example, mono is 1, di 2, tri 3, tetra 4, and then penta, hexa, hepta, octa. Those are quite common prefixes. Nona is 9, deca is 10. Okay, once again, pause the video, try the questions, and when you're ready, click resume. So hopefully you got the same thing. Once again, covalent compounds are usually easier. So the past kind of 2 sections here were about kind of writing formulas. Now we're actually going to name formulas. So let's go back to ionic compounds. We have Na2O and we're going to name it. This is a lot more straightforward. Step 1, find the first element on the periodic table. Na is sodium, sodium. Step number 2, we're going to find the next element on the compound. But remember, because it's at the end of the name, we're going to change the ending to an IDE. So usually we keep the first syllable and then we add IDE. So for oxygen, over oxygen, oxygen becomes oxide. And then we're just going to place the 2 names in order and with a space. So we have sodium oxide. And once again, it gets a little bit more complicated if we have multivalent metals here. So for example, copper, Cu, if you look at it on the periodic table, you'll notice that it can be of either a plus charge or a 2+ charge. What you have to do to figure out is you have to uncross and go backwards. Okay, so if I look at this example, Cu2O, you might be tempted to say, well, that subscript is a 2 behind copper, therefore I'm using a 2+ charge. Okay, and that is wrong because remember, when we're writing ionic compound formulas, we cross the charges. So let's uncross the charges. We have the 2 going back and the invisible 1 going back. And so now you'll see that on copper, we have a charge of 1, oxygen was a charge of 2. Therefore, the copper charge or the copper ion that was used in this example is that of a +1 charge. Step number 2 and 3 are the same thing, write the first element. So copper, don't forget, because we have to distinguish between the 2 possible charges, we're going to use Roman numerals. So copper 1, and then oxide, everything else is the same. Now usually, back in kind of Science 9, as you started kind of playing around with Roman numerals, some students start Roman numeral everything. Okay, so that's not correct. The only time you have to use Roman numerals is if you have multivalent elements, or most of the time, it's going to be part of the transition metal, that middle block of the periodic table. Okay, so once again, it gets a little bit more complicated. If we have polyatomic ions, when you look at it, you'll notice that there are a lot of elements. There's more than 2 elements, and if you have more than 2 elements, that's a really good hint that you're dealing with a polyatomic ion. NH4, look at the back of the periodic table, it is ammonium. Second part of the compound, we have CO3. Okay, that is not a single element, and so we're not going to change the ending to an IDE. Rather, if you're using the polyatomic ions at the back of the periodic table, they're good. You just use them as is. So CO3 2- is carbonate, and so when you put the two together, you get ammonium carbonate. Okay, once again, we hit some practices here, so pause the video. When you're ready, then click click continue again. Okay, so hopefully all the names of your chemical compounds are the same as mine. Once again, if you have any questions, please ask, as this is going to become very important for our chemistry unit. So the last section here is going to be naming compounds for covalent compounds, and for many, this is kind of the easiest one. You take a look at it and you just add prefixes. So example 1, I have CCl4. Okay, don't use charges. Covalent compounds have nothing to do with charges. We're going to use the prefixes. So in step 2, it says use prefixes to give the number of each element. Carbon, I only have 1, so monocarbon. Chlorine, I have 4, so tetrachlorine. Once we got that, then we're going to start using, or we're going to start cleaning up. If the first element, there's a few rules here. If the first element has mono as its prefix, we're going to ignore it. Okay, so if we have monocarbon, mono being the first one in its name, we're going to ignore that. And don't forget to change the ending of the second element. So instead of chlorine, we have chloride. And so our final answer for CCl4 is carbon, because there's only 1, and tetrachloride, because we have 4 chlorines. And that's it for this section on naming and writing chemical formulas. I hope to see you in the next lesson.